we've managed to piece together the entire genome of a pathogen that caused the plague of Justinian. So this was a plague that hit Rome in 540 AD and spread out throughout entire Europe, killing 50 million, up to 100 million people. And we've determined now that it's actually a form of plague, bubonic or septicemic plague. And we can make now direct comparisons to later epidemics of plague. For example, we know the Black Death hit Europe again 800 years later. And if we now, having these two ancient genomes and having modern day genomes, like the current outbreak in Madagascar, we can compare and contrast them over time. And what we see with the plague of Justinian is that we had this epidemic that probably erupted in China, traveled the Silk Road into Europe, decimated Europe, and then went extinct and disappeared. And then fast forward 800 years, we have another epidemic that seems to have traveled the same route, erupted in China, traveled along the Silk Road into Europe, and wiped out again 50 million people, but then was disseminated across the globe. So the Black Death, the dissemination of the plague was much more successful in the Black Death time. So the Justinian went extinct, the Black Death sort of maintained itself to present day. And so the question is, they both killed 50 to 100 million people. What was inherent in those genomes that made them so deadly as opposed to outbreaks that we see today? I think one of the most important implications that come from the study is we know that this plague was an epidemic that came out and then went extinct. And then we fast forward 800 years and we know the Black Death again was another epidemic of the same bug that came out and then disseminated across the globe. So the point is that there are rodents still today that harbor this infection that can continue to emerge. And so by understanding how those things happen, what those changes are in the ancient bugs that cause them to be so deadly is critical for understanding how future epidemics could happen and can, in theory, be controlled.